Hello, you're welcome back. All right, still on technique of differentiation. So here we're going to be looking at another technique. Okay, so we'll look at technique for finding the derivative of an implicit function. Now the question is, what's an implicit function? Now an implicit function is a function whose variables cannot be separated from each other. Of course, you know very well that the derivative of a function is always given in the form of y equal to the function of x. Okay, so there are two variables involved. Now we have y, which is the dependent variable, all right, found at the right hand side of the equation. Then I have x being the independent variable. Okay, function of x being the independent variable found at the right hand side of the equation, and they are being separated. Okay, y at the left hand side, y s in the right hand side. But there's some so such a function, okay, that is separated, whose variable is separated, all right, is called explicit. So the function is explicit in nature. But a function is implicit, okay, when the variables cannot be separated. Now let's look at example of implicit function. Okay, for example, we have something like this: x squared y minus 2y squared 2y squared x equal to 0. Okay, this is an implicit function. There is no way I can actually separate the variable, okay, x from y. So it's an implicit function. Now let's look at b. Okay, let's look at a situation where you have s cube. Okay, then dot two x square minus y cube. Let's plus y cube. Okay, y cube x, then plus 3x equal to 0. So this is just an example of implicit function. Okay, so now how do we actually find the derivative of the implicit function? Okay, now for me to find the derivative of the implicit function, okay, let me use this example I have above all this implicit function. I'll use it as an illustration. So since the variables cannot be separated, okay, so we actually find the derivative implicitly. Okay, so that means in variable, like, I have to also impose I have to find the derivative inside the function. Okay, of course I don't need to separate the variable. Then I have to find the derivative of both the independent variable and the dependent variable of the function. All right, so that's exactly what I'm going to do. Now I'm going to show you the so let's say the question above, the function above, I'm supposed to find the derivative. Okay, so now I'm going to show you how I will actually achieve that. Let me start with a. Now that means I'm going to differentiate both the independent variable x and of course dependent variable, okay, in the function, then applying the whatever rule I need to apply, okay, in my differentiation. So please take note of the rules that you're applying. Okay, then look at how it goes. Anytime I differentiate x, remember if I'm differentiating x, that means I'll have to differentiate s with respect to x. Okay, if I'm differentiating y, I have to differentiate y with respect to s. Why? Because my answer, what I'm looking for, is dy dx. Okay, so I'm looking for the at the end of the day, what I'm looking for, what I'm to find the derivative of this function is divide the s, okay, and this one also divide the x. So now look at, if I differentiate x implicitly, okay, because I'm going to differentiate them implicitly in the function, right? So if I differentiate s with respect to x, then you know very well that I do not have to attach, I won't attach any divide x to the function of x. Why? Because if I differentiate x with respect to s, that's going to be, it's like saying differentiating as the x with respect to the x, and of course the s will cancel the x, so I won't attach any differential function or derivative, okay, derivative symbol to that the result. But it's only when I differentiate y, okay, with respect to x, that after differentiating the y I have to attach the y the s to that derivative. So now let me start with this, okay. So solution for a, I will have to, now if you look at, I have a here, I have s square y, okay, then minus 2y square x. So if you look at this s square y, this is a product function, all right, and what, because it's a product function, s square times y, I have to keep one constant and differentiate the other. Let's say I'm keeping x square constant, all right, then I have to differentiate y. If I differentiate y, of course I'll have 1, okay, because y is something as y is power 1, so I'll have 1. Now because I differentiated y, I have to attach dy dx. Of course 1 times dy dx is still going to be dy dx, okay, so that will be dy dx, x times dy dx. So now I'm done keeping x constant. Now I have to, and I bring plus, okay, because the product rule. Now I have to keep y constant. I have, then I differentiate x. If I differentiate x square, of course you know what I will have. I will have 2x, okay. Now I'm not going to attach dy dx to, because I just differentiated x. Please take note, anytime you differentiate x, you don't attach dy dx to it. Then of course I now go to this side. This is also a product, 2y square dot x, okay. So let's say I'm keeping 2y square constant, then if I should differentiate x, I will have 1, okay. Then of course plus, this time around I'm keeping x constant. If I differentiate 2y square, of course you know what it's gonna give me, it will give me 4y. This is gonna be dot 4y, because the 2 will go at the back, okay. So I got 2 times 2, that's 4y raised power 2 minus 1, and 2 minus 1 is 1, so y raised power 1 is still 1, that's why I have 4y here. And don't forget that anytime I differentiate y, I always attach dy dx, okay, to it. I always multiply by dy dx. Then remember, don't forget that everything is equal to 0. Okay, so now as you can see, I have dy dx, okay, 2 dy dx in this expression, so I need to factorize it out. But before then, let me simplify my expression. So I'm having s square dy dx, then of course plus 2x multiplied by y, that is going to give me 2xy, then minus 2y square multiplied by 1, that's going to be 2y square, then plus 4y multiplied by x, that's going to be 4yx, 4xy, let me just, okay, in ascending order, 4xy, okay. So don't forget dy dx. So collecting like terms, how do I collect that terms? I collect all the expression that has dy dx together, then I'll take the one that doesn't have dy dx to the other side of the equation, okay. So let's do that. So if I collect this like term, I can now factorize. Dy dx is the common factor, okay. Then open bracket, the other factor I put inside the bracket, which of course is s square. Then for this, the other factor is plus 4xy, okay, is equal to, now I'm taking the plus 2xy, okay, the one plus 2xy minus 2y squared to the other side of the equation, okay. Now when minus 2y squared goes over, it becomes plus 2y squared, so I'm having 2y squared, and of course plus 2xy, when once you go over, it becomes minus, that's minus 2xy, please pardon me, minus 2xy. Okay, so now you know how I can now get my dy dx, okay, by dividing both sides by x squared plus 4x. So my dy dx is equal to 2y squared minus 2xy, then divided by x squared plus 4xy. Okay, so I hope that is well understood. So now let's look at the B part of the question. Let me clean up so that I will have space. Okay, so now let's see how this one goes. This is the product, right? So now let me keep the s cube constant. Then I differentiate. Okay, this should be 2, please pardon me, this is 2y squared. Change that. This should be 2y squared. Okay, so I now differentiate 2y squared. If I differentiate 2y squared, I will definitely have 4y. Then plus, now remember I kept s cube constant. Then the next thing I'm gonna keep 2y squared constant. Then I'm gonna differentiate s cube. If I differentiate s cube, I will have 2s squared. I will have 2s squared. Alright, then of course plus let's do this now. Let me keep y cube constant first. Then I differentiate x. If I differentiate x, okay, I just forgot, there's something I forgot to do. Okay, I didn't add dy dx after differentiating y here. So don't forget that. For this, okay, I differentiated y, I need to add dy dx to it. Okay, then of course let's do this. I keep y cube constant. I differentiate x. If I differentiate x, I have 1. 1 times y cube is still 1. Okay, plus this time around now I'm keeping x constant. Then I differentiate that y cube. If I differentiate y cube, I have 3y squared. Okay, then don't forget that I need to attach dy dx to it. So the entire thing is equal to 0. So now let's multiply this. So this is gonna be s, or better still, let me collect times and factorize dy dx, open bracket. This is gonna be 4y minus multiplied by s cube. Okay, so it's gonna be 4s cube y. Okay, then for this one now I have 3y squared, 3 times 3y squared. Okay, so that's gonna be plus 3x y squared, and I'll close it. Okay, then according to what I have there is, okay, I'm not done. It's equal to, yeah, it's equal to 0. Then I have to take the other expression that is not attached to the y dx to the other side. Of course, if I take y cube to the other side, it becomes minus y cube. If I take 2y square times 2x square. Okay, remember 2 times 2 is 4. Then I have x square y square. Okay, so what I'm having is, and if I take it to the other side becomes minus, that's gonna be minus 4. Okay, x square y square. So now I can now get my divide the x. Divide the x is going to be equal to y cube minus y cube, pardon me, then minus 4x squared. Okay, so I'm going to have minus y cube minus 4x squared y squared. Okay, then all divided by 4x cube y, then plus 3xy squared. So that is how implicit function actually works with differentiation. Okay, so we are going to look at more question in implicit function. Okay, all right, see you in the next video. Thank you.